Yeah.
Okay, so for question 1, we drew a picture of replication. So here's the 5' strand, or side of the strand, and the 3', so it's the 3' and the 5'. And here's the DNA helicase separating the two strands. And then here we have the ORIC, which is the origin of replication, so that's where it all starts. And then we have the leading strand here and here, and then we have the Okazaki fragments starting here going. And then we have our RNA primer in between, which our DNA primase is creating, and then our DNA polymerase 3 alpha subunits are here, where one does the leading and one does the lagging strand. And here we have our DNA polymerase 1, which is taking out the primers and filling it with DNA.
Yeah.
Okay, for question 2, part A, it says this protein complex synthesizes primers in eukaryotes. And we said DNA primase, just like you can see over in our picture earlier. B is this protein promotes the separation of AT-rich sequences within ORIC, which is the DNA A. C, this subunit of DNA polymerase 3 contains proofreading activity, which is epsilon. Part D, this protein synthesizes the leading strand in eukaryotes, which is DNA polymerase alpha. E, this protein displaces DNA polymerase 3 from the chromosome to terminate replication. We said it's the TUS. F says this protein has 5' to 3' polymerase and 5' to 3' exonuclease activity. So we got DNA polymerase 1. For G, this protein introduces negative supercoils into the DNA ahead of the replication fork. So that would be the DNA gyrase or the topoisomerase 2. And H, this protein binds directly to ARS elements, and that's the ORC. I, this protein prevents DNA strands from annealing during replication. That's the SSBPS. And for J, this enzyme seals Okazaki fragments into continuous strands of DNA. That's the DNA ligase.
Go.
Okay, so for question 3, it wants to know about enzymes in DNA replication. So for A, it wants to know how many enzymes consume ATP. So we have DNA helicase, gyrase, primase, ligase, and then the MCN helicase. For B, it wants to know it wants us to list 5 enzymes that consume DATP. And so we found DNA polymerase 1 and 3, and then DNA polymerase alpha, delta, and epsilon. For C, it wants to list 5 enzymes that have 3' to 5' exonuclease activity. And so that's DNA polymerase 1, 2, and 3, as well as delta and epsilon. And then for D, it wants to know one enzyme that involved in replication that uses DNA as a template to synthesize RNA. So that's DNA primase. And then for E, it wants to know what enzyme uses RNA as the template. And so that's telomerase.
Yeah.
Okay, so for number 4, she did do a video on this one, but I just wrote the segment on here, 5' to 3', and then we have the primer, and so we know that the other one has to go 5' to 3' here. So once you put that in, then for number A, it talks about the nucleotides in the reaction include DATP, DCTP, and GTP, and DTTP. And so you can just synthesize from here back, and so I put 5' because this end is closest to the 5' end, and then this is the 3' end, and then you can go across without any interruptions. For part B, because of the DCMP, it gets interrupted, so you can only get A here. For part C, you can only have A and C because it gets interrupted at A, and then for part D, you can do A, C, T, because it's interrupted because of the GTP.
Okay, so for question number 5, we drew it up here, or we projected it up here. So the first question is asking us which one of the proteins from the list above was found in prokaryotes. And we went through the reading, and the ones that we found were in prokaryotes specifically were DNA gyrase, DNA polymerase, DNA primase, DNA A, TUS, and DNA polymerase 3 alpha subunit. And then for B, looking at the mouse, so it's going to be a eukaryote. We're looking for all the proteins that are involved in the eukaryote process. And so we found an MCM helicase, CDC6, DNA polymerase epsilon, DNA polymerase alpha, DNA primase, telomerase, and pCNA. And then for these questions, for question C, we're looking at which protein is involved in compaction. And we said DNA gyrase because it induces supercoiling, helping to compact the DNA, helping to compact the chromosome. And then in part D, it talks about the proteins involved in initiation. And we said CDC6 because that's released in order to start replication. DNA A, which has to be bound to the DNA A box units. And then MCM helicase, which is released and helps start the replication between the chromosomes. And then for part E, which of the proteins are involved in termination, and that's TUS, which is termination utilizing substance, which helps to initiate termination.